Hello everyone, my name is Zhong Wang. I'm a PhD candidate in the University of Alberta. Today I will be presenting our project called Multi-Dimensional Mapping of Confined Areas using a Hexapod robot with integrated sensor data and SLAM. Let's start from the problem statement and motivation. This picture was taken from a real confined space inspection where the inspectors need to inspect air intake duct, wastewater drainage pipe, abandoned conduits, electrical conduits, hot steam pipe, and cold water pipes. This space is relatively narrow. It only has 0.7 meters in height and about a meter in width. This case can demonstrate multiple risks for confined space inspections, for example, toxic gases, flammable gases, depletion of oxygen, limited visibility, and potential extreme temperature. Apart from these risks, there are also many psychological challenges. For example, anxiety and fear, claustrophobia, and difficulties in concentration. All these risks and challenges will heavily impact on the safety of inspectors and the quality of inspections. To address these risks and challenges, there is a trend of using robotics for hazardous confined space inspections. However, existing studies focus on geometric mapping or specialized sensors. They often lack of integrated multi-sensory mapping for confined spaces, and there's a need for richer environmental representation. To this end, we have started a project to design a robotic system, and I'm about to present our first minimum viable product. As you can see from this figure, there's a server side, which is a robot, and a client side, which is normally a PC or a laptop, and they are connected through TCP/IP protocol. This is our robot. At this stage, it's called Bubble, named by my supervisor's daughters. The mobile platform was built on Hibernate Jet Hexa. It consists of a LiDAR, a Raspberry Pi, and an integrated sensor. The robot collects data by the Cartographer SLAM algorithm and fuses sensor data with SLAM map by the IMU sensor. So basically, this robot is traveling while collecting data. You may be wondering, or not, what about areas outside the robot's trajectory? So we use interpolation techniques to answer this question, and for this work at that time, we used the bilinear interpolation method. Assuming we have a known trajectory with 5 points of sensor data, A1 through A5, and we need the sensor data of B1 and B2. The interpolation techniques choose the related known points to calculate the unknown points. In this case of bilinear interpolation, the assumption was they were linearly related. There are also other interpolation techniques like kriging, inverse distance weighting, and radial basis functions. So in summary, there are 4 sections in our robotic system: data collection, data fusion, interpolation, and map generation. We use SLAM for 2D or 3D mapping, and sensors for sensory mapping. We use IMU to fuse sensory map with SLAM map, and use ROS time for correction. We use bilinear interpolation at that time for interpolation and generate the map by plotting algorithms like matplotlib or an Origin Pro for retouching. We deploy this robot to a pilot experiment, and the goal is to investigate the robot system's capabilities for constructing the multi-dimensional map. This experiment was conducted in a mechanical room, as you can see in this picture, in the Li Kai-shing building at the University of Alberta. The robot equipped a humidity temperature sensor, the DHT22, at a sample rate of 0.5 Hz. And we applied 2D Cartographer SLAM technique. These are the results. We managed to have the multi-dimensional maps. The left is the temperature and the right is humidity. The black line is the trajectory of the robot, and the plotting algorithm will remove the sensor data if there's an enclosed area identified by the SLAM. As you can see on the figure, there are 4 reddish blocks. These are the enclosed area identified by the SLAM algorithm. So when we fuse the map together, the sensory map will be blocked by these enclosed areas. There are many limitations for this work, namely limited sensor suite, restrict environmental data. Raspberry Pi 4 has a huge computational constraints for real-time processing. Bilinear interpolation may oversimplify the heat maps. Thank you so much for your time and attention. My name is Zhong Wang. I'm a PhD candidate in the University of Alberta, and my supervisor, Dr. Vicente González, hopefully he's somewhere around this screen, will answer your questions. Thank you.